Hi, and today we are going to go through the Lab 3 tutorial of DataLab in EE542 course. So as you can see, I have all the example files which we are going to be executing in today's experiment. I pasted it in my home directory, and let's start things off. So today we will be trying to create virtual nodes in DataLab and try and look of how to create containers as well. So as you can see, I have example1 file here. We have a center node, and then we are now trying to connect 9 other satellite like nodes. So, and this is example 2 here, and here we have a center node with 6 other satellite nodes. So let me now go try and create an experiment. Let me open PuTTY and access my account. So yeah, so let me try creating the experiment 1 with example1 file, which is like trying to create 9 nodes as a QEMU container. But you can see there I got an error message saying that there can only be a maximum of 7 experimental nodes in 7 QEMU nodes in an experiment. So now I'm gonna reduce my number to 6 satellite nodes and 1 center node, as you cannot create more than 7 QEMU nodes in a container. So I've changed it now. Yeah, I modified the file, and let's try creating again. And yep, now you can see that the experiment is successfully created. So it's always helpful to keep in mind that you can't create more than 7 QEMU nodes in a container. So yeah, let's get to example 2 here, where in this part of the code we'll be creating 7 QEMU nodes within a container. So yeah, let me create our second experiment today. Let me check whether, yeah, so yeah, it has been modified. Yeah, so now I'm creating with the name experiment 2. Yeah, so experiment 2 is successfully created. So let's now go and look at the visualization and partition images for experiment 2. So let me use FileZilla and go to my experiment 2 directory, which is nothing but /prods /EE542. So yeah, now I'm the /prods container. So let me go to EE542 and let's go to the exp folder and to our experiment name, which is lab3 ex2. So yeah, within the containers folder we can find the visualization and partition, which has been created from the .tcl file. And let's take a look at the visualization image. And yeah, as you can see, it's just a 7 nodes connected with a central node. let's look at the partitions. Yeah, let's take a look. That's the visualization again. And yeah, so all the 7 nodes connected with the central node. And so yeah, so the point here is that all the 7 QEMU nodes are within a single physical node, so we can able to appreciate it from seeing the partitions image. So now let's try swapping in experiment 1 so that we can access an virtual node. So yeah, so it has been swapped in. Now I'm accessing the physical node which was created in experiment 1. Oh, sorry for the typo. It should be a dot. Yeah, so now we're successfully logged into P node. Let's try and access node N0. So yeah, now we are in within the virtual node N0. Let's try pinging a node. Let's ping the center 3 node, and as you can see, we were successfully able to transmit and receive the packets. Now let's check the space allocation and the operating system for node 0. So df-h gives you the space allocation details. And now let's change directory to etc and execute the command cat lsp release, and you can see that Ubuntu 14.04 is installed within node 0. Now let's get to the next part of the tutorial. Here we are gonna create another experiment 3. So let me open example 3 file to go through the commands which we are going to execute. So example 3 here, we specified that the central node is of a QEMU type, and the other 6 satellites are also of the QEMU type. So we create 6 satellites attached with the central node, both with QEMU type. So let me create the experiment again so that we can take a look at the visualization and the partitions. So I'm creating with lab 3 experiment 3. So we're successfully created. Now let's take a look at the partitions and visualization image. I'm accessing my experiment 3 directory. And get into the containers folder. Yeah, and you can see 6 nodes connected with a central node. And then let's check out the partition image. And here you can see all the 6 nodes with the central node is under a same physical node. So now let's take a look at example 4. Here we have specified 2 physical node types. So we'll be creating 2 physical nodes with a central EMU node and 4 other EMU nodes. Let me create the experiment again. So let me get to the file directory. So let me access the containers folder and take a look at the partitions image. So again, the visualization image is similar to the other three examples, but as you can see, the partition image is a bit different because of the existence of two physical nodes. And yeah, so that's it with example 4. Let's go to example 6 now. So in lab 6 we will be creating 3 separate networks, each with 20 nodes connected to a central node. So as you can see, we have used pass partition for the center node as well as the sub nodes in the network. So let's create experiment 6. And experiment 6 is created. Let's access the partition and visualization files. So let's take a look at the visualization image for experiment 6, and you can see here 3 subnetworks, each with 20 nodes connected to a common central node. Let's take a look at the partitions. Here we used pass partition, so it looks like this. So we have 8 physical nodes, each subnetwork having 3 physical nodes, and the central node itself of being a physical node, and then one of the subnetwork having just a single physical node. So now I have simulated example 6 with a pack factor of 2, and you can see here each physical node has only 2 nodes attached with it. So you can increase the factor by any number you want. And now let's take a look at the same experiment run with the passback option. And here is the passback option. As you can see here, the nodes are arranged in such a way that it can provide the best effort service possible. Now let's look at the nodes only option. So I use the nodes only option here in the same example 6, and you can see how it has been regrouped into. Now let's look at the pass size factor, where I have given size for each group, with group 0 having just 1 physical node, and group 1 having 2, group 2 having 3. So depending upon the pass size, it has been allotted. And let's take a look at the last possible combination here, and this is a mixed group, a mix of the pass size and the pass back options. So now let's look at the topology like we were supposed to create. And here we have to create this topology with 5 nodes and 3 routers. And let's look at the visualization here. So you can see this having 2 LANs, and now we did so I used 5 physical nodes to represent this topology, and it can be also done under 3 physical nodes as well. So this completes the tutorial, and thank you.